So what I'm going to talk about today is, it's interesting the conversation we just had was about databases, because I'm going to talk a little bit about why Erigon's different, and where do I need to click this at? So it doesn't seem to... how do I move? Right and left, okay. Okay, cool. If I click the right button, it works. So basically what I want to do is talk about a little bit about the features of Erigon 3 and what makes it different. And it really is around, for Erigon 3, for Erigon in general, we've spent most of our existence thinking about file format and how do you move data from a database to a to flat files and then distribute it across the network. I mean, it's sort of interesting that actually now lots of other people are talking about it. At one stage, we were the guys who sat in the corner and coded this stuff, and everybody else was doing different things. But basically, we have kind of three things. We have what we call, got a typo, but QLSMDB model. So we've got a database which is like a log structured database that has this B tree at the top of it, effectively. For us, it's a continuous database. It's just like two things built together. And in our log structured format, we have effectively what we call page file determinism, which means that effectively, actually I might as well click to, and then the third thing is we have binary distribution. But let me talk a little bit from a picture. So effectively what we've done is we've defined our database, so the file structure, other than the database at the top here, is always a consistent deterministic structure on every node that Erigon runs on, effectively. So, and part of the reason that we've made this split is so that we can distribute the data between machines in a binary format without having to change it, effectively. Now, and this is really the change from Erigon 2 to Erigon 3 is adding this data for state as well as blocks. Now, why have we done that? We've done that because Erigon 2 had a tightly structured format that we put into MDBX, and although it was efficient, it ended up with us having large DBX data files that were, I mean, they were smaller compared to maybe Geth, but for the larger chains we were working on, you end up with an 8, 12 terabyte data file, which has got two problems. One is it's not very operationally easy to deal with, and the other thing is, in practice, it needs an NVMe drive in order to make it perform. And in cloud environments where most people run, NVMe drives are premium commodities. So actually running an Erigon archive was quite an expensive activity, because basically you had to have all these local NVMe drives. So we kind of split things into files, and when we split things into files, we basically made sure the file organization was static once the thing had been written. Which basically means that, as I say, the things don't change between nodes. And effectively, we've also got a model where we'll keep things in the database, and then we'll write to files, and then over time we'll write to larger files, effectively. So essentially, as the data becomes aged, it gets moved into larger and larger units. Now, the practical reason for that is that it gives you a smaller number of files, and actually gives you a performance benefit between the file and the paging system, basically. And as I've just said, basically every node does the same thing. So you can take a file off one node and communicate it to another, and it will always be the same, which means that effectively we can share our snapshot data with no further processing, and you can run the whole chain off of it. The only thing that you need to do is put the kind of what's now quite a small database on top of it. So Erigon's distribution model is copy this data around using BitTorrent, and then that gets you very close to the tip, and then you just fill in the tip in the database. Now, at the moment, we've got an operational distribution model that distributes these things every week. So it's better to sync Erigon on Monday than Friday, because what happens is over the course of the week, you end up with having to do more database processing. And yeah, this is just a picture of kind of what does this mean big picture wise. We kind of see it as we've got, and also because Erigon now runs the CL and the EL, we kind of have got this. We've got this stage where, for both of these things, we keep snapshot files. So we're doing this kind of process of doing the processing, creating a shared binary format, and we kind of see it as right. Actually, what we've done is we compiled the chain, because if you think about the way a compiler linker works, effectively it's taking the code and turning it into a shareable binary form. We've effectively done the same thing. Now, the advantage that gives you is kind of two things. One we're making use at the moment is we can torrent things around. But what we also, and we haven't got onto working on this, and I think I talked about this time last year, is we can also virtualize this. Because basically this is a binary format and you can load it, you actually don't necessarily need to keep the whole blockchain on a single node anymore. As long as your network is fast enough for you to be able to have index data and you go and get the bit you need, you've kind of got what I kind of describe as an internet scale blockchain at this point, because the data store no longer has to be, what can you fit proximate to a single processor, because as long as your network time is actually quick enough, you can actually store it elsewhere. And what is quite interesting since we've been running Erigon 3 is our BitTorrent clients, now everybody's actually started operating the chain, can move 200 gigabytes a second. No, can move 200 to a gigabyte of data around the network per second, which actually means that this is almost practical, because if you think about the chain model from, there's a lot of things that are doing the last 100 blocks, and there are far fewer queries across historical data. If you don't need much historical data, you can probably go and get it across the network. Although we basically haven't got that piece of the system working yet. We've not tried it. Now, the other thing I wanted to talk about, so that's the whole theory. Now, Erigon 2 to Erigon 3 is something that I think this time last year at DevCon, I talked about it because we were just launching. But in fact, effectively, I think I've got the timescale here. Yeah, so DevCon last year was about November, and we basically were on our alpha still, which we launched in July. And effectively, we in our minds, by the end of the year, we were going to have everybody using Erigon 3. In fact, it's taken us quite a lot longer than that to get from kind of this model that we had working, that seemed to work, to an operational system. So effectively, yeah, we launched in July. By January 2025, I think we were happy to call it beta, which means it kind of mostly worked. And what from then we started doing was getting Erigon basically working, getting people to use it. Same time we were trying to maintain Erigon 2, and we kind of hit a hard stop for Pectra because we realized that we only had the Pectra changes in Erigon 3, and we couldn't really backport them effectively enough to Erigon 2. So unfortunately, we had to tell everybody, if you're on Pectra, you've got to go to Erigon 3. So that gave us like a bit of a bump in the road where we had to force everybody to use our new product, which I think wasn't ideal, especially when you can see by August we'd got to Erigon 3.17. So you can see we'd gone through quite a lot of fixing during that stage just to get to a point where I mean, the good news is we got everybody onto Erigon 3. The bad news is we forced everybody to get on Erigon 3, which was probably not completely planned. But I think where we are with it now is Erigon 3.1 has got a couple of important features added to it. Primarily I described the snapshot publishing process that we had. What we basically had in Erigon 3 was no real file versioning. So we had these snapshots, but there was no indication in the files whether they changed format or they changed content. And in the bug building process, what we realized is if you've got this binary format that you're delivering, actually you've got a version of the binary format as well, because otherwise you're kind of constantly pushing changes to people when you fix bugs. Because when you fix bugs, you also potentially change either the content or the format of the files that you're delivering. So Erigon 3.1 fixed that and is probably a lot more usable version as a piece of software than actually Erigon 3. And the other thing that we ended up discovering we needed to deliver was when we originally delivered Erigon 3, one of the things that we were trying to do was deliver it without logs and receipts. And that's because basically, in theory, when you're running an RPC node, because Erigon 3 fetches things at a transactional level, we kind of thought it was going to be possible to reconstitute the logs and receipts on the fly for RPCs. But what we learned was from a RPC scaled performance perspective, that doesn't really work because you're forcing the node to re-execute everything, and that's actually quite a load on the. It's quite a big load on the CPUs rather than just delivering the data. So there's a trade-off here because basically receipts and logs almost double the size of the stored data. So effectively, the way we've delivered it is these things are add-ons because if you're running a node and you don't particularly care about log provision or the bugs associated with it or the fact that it's unreliable, you can just run the model that we've got and it saves you a lot of data, basically. So it's a trade-off. So Erigon 3.2 is a feature release for Fusaka, and then we've just released Erigon 3.3, which is essentially implementing archive get proofs, which was a feature that we didn't have in 3.0. And again, this is a cost. It will become a plug-in feature you can turn on because I think for ETH mainnet, our archive size for get proof is 4.5 terabytes, I think. So it's quite a big delta on the 1.7 terabytes that we have for an archive. So if you really don't need to support historical get proofs, you probably don't want to carry that 5 terabytes of disk. So that's the story of us getting 3.0 out. I think we probably have spent a lot more time this year working on it than we expected to. And why did it take so long? So one of the things with Erigon, it's used for Ethereum, but it was also, we had a support contract with Polygon. And Polygon is a lot bigger than Ethereum. I mean, the talk earlier was talking 2x the Ethereum state. I think Polygon is probably 3 or 4x the Ethereum state. And it's, because it's 2 seconds a block, it goes a lot faster. And I was computing. It's about 50 megagas. So it's a block every 2 seconds. So it feels a bit like Polygon is at the moment where Ethereum plans to be in 2 years' time, which is interesting for us because it kind of says, well, we can probably support the growth because essentially it's just getting to where something we know was. But one of the things that we did learn was the whole release process of software is a lot harder once you get these big changes. So it's not just how do you maintain it operationally, it's like the whole testing process is really quite slow if you want to make a fundamental change to your your tech stack and you want to make sure it works for the whole of the history, this is quite a big endeavor, and you end up waiting a lot of time to find out whether you've got a bug or not. And I think that the other thing for us is we kind of spent a lot of this year trying to improve our processes, because Erigon has probably rightfully a reputation for being, it saves you data. It can be fast for RPC, but it can also be frustratingly unreliable, because our change processes are like, we check the stuff into main and expect it to just work. Our QA processes, to be frank, up until this year have been ad hoc, to say the least, and also kind of our approach to software engineering has been, well, we're an R&D shop, we'll try some experiments and we'll leave them in the code base. Which makes it kind of actually difficult for us as a team, because you get all of these things that somebody did 3 years ago that's left there. So what we've been trying to do is just improve our QA and software engineering processes, because now we've got to kind of Erigon 3 as a product, we want to make it scalable and stable, which is a bit of a culture shock for us as a team. But you know, it's kind of, we feel we're now getting to a better place. And so, the question is, was it worth the change? Because this change was, the reason I'm mentioning this is I can hear conversations about moving from moving state out of the database into storage, and I think although it's a system step and the performance implications, our experience of this is, actually that transition out of the database can lead to a whole set of edge cases that you may not realize exist until you do that, and you get things you expect to work, and then somebody does a historical query and it doesn't return the result you got, and then when you interrogate it, you realize because actually there's a bug in the code that's retiring and pruning data, essentially. And you quite often don't see those bugs until, sometime down the line. And as with most bugs, the problem is the further away it is from the actual thing happening, the harder it is to discover. So bug chasing is quite a difficult thing before. I think the other thing is that we believe it's worth it, because we think actually with Erigon 3, there's a whole new flexible way of working, in that because we're now not worried about keeping the data in the database, and we know we can distribute it across the network, we've got the potential to do a whole set of more flexible things with our node than we did before. Somewhat frustrating that we haven't started doing it yet, because we've been trying to make the node work, but actually now we're there. I think there's a number of opportunities that we think we can exploit. What I want to do now is say, okay, fine, what's one of those opportunities? And it's a bit timely that effectively one of the things Erigon's always been quite bad at is at the tip performance. And because we got more so Erigon 2 was like a big batch processing machine, which is why it didn't really work very well at the tip, because you needed to run the whole batch over and over again. It was very quick at that, so it was very quick at basically, or comparatively quick at getting to the tip from zero. It kind of would take a week or so, or it would take for Polygon it would take like only 8 weeks, small amount of time. Now the thing is, now we can distribute the stuff, our chain binary. It takes a few hours to get to the tip, so you kind of get a slightly different attitude to life. You don't like start the thing and then go, well, I'll come back tomorrow and maybe it'll be finished. You kind of get in, so to start an Erigon node on a Monday, it's different on a Friday because it's not quite at the tip. It can take it 15, 20 minutes to start. So now it's like dealing with a normal software product, as opposed to a node. But as part of that, we've started looking at kind of how do we improve our execution at the time. How are we doing for time? I'm at it. Okay, fine. So so basically we've just looking at how we execute, and we've put in place a parallel execution engine, which we've just about got live, which is great because now we can plug BAL into it. That's my run out of time.
Excellent. Yeah, I know there's just more content than we possibly can cover in a period of time, and actually you've got one of the largest question sets I've seen yet in there.
Ah, dear. Well,
But,
actually, I'll keep talking. And I'll have time to answer it.
but unfortunately, I do want to keep us going in today's agenda. So please, a big round of applause for Mark here.